All right, welcome everyone. We're diving into the fundamentals of epidemiology, and believe me, this stuff is absolutely vital for any of you going into dentistry. We're going to break down the core concepts, the very foundation of public and oral health.
Okay, so here's our game plan. First, we'll get the big picture. Then, we'll talk about how we actually measure health. After that, we'll peek into the epidemiologist's toolkit, touch on avoiding errors, and then, the best part, we'll tie it all back to what you'll be doing in your dental practice. So let's kick things off with a big question, one that really gets to the heart of what we're talking about today. Why is tooth decay more common in some communities than in others? You know, it's not just about one person's brushing habits. It's way bigger than that. It's about patterns, environment, access to care, and uncovering those patterns, well, that's exactly what epidemiology is all about.
Right then, let's jump into our first section, the big picture. This is where we look at how epidemiology helps us answer those massive questions, how it bridges that gap between treating the one patient in your chair and understanding the health of a whole community.
Okay, so here's the formal definition, but what does it actually mean? The key thing to get here is that epidemiology isn't just about, passively studying stuff. It's active. It's about figuring out the distribution, the who, where, and when, and the determinants, the why, of health issues. And then, and this is crucial, we apply that knowledge to actually control health problems.
And this field has quite a history. I mean, it goes way, way back. You've got Hippocrates, around 400 BC, noticing that our environment affects our health. Then fast forward to 1854, and you get John Snow, a true hero of epidemiology, who famously traced a whole cholera outbreak in London back to a single water pump. And then in the 1950s, things got even more sophisticated, with the big studies that finally nailed the link between smoking and lung cancer.
Which really leads to this brilliant way of thinking about it. An epidemiologist is basically a disease detective. Seriously, they're out there looking for clues, hunting for patterns, trying to solve these big public health mysteries. Just like John Snow with his water pump, today's oral epidemiologists are tracking down the causes of oral cancer, or figuring out the risk factors for gum disease.
Now, any good detective needs a proper set of tools, right? And for an epidemiologist, those tools are all about measurement. That brings us neatly into our next section, where we're going to look at the essential numbers that tell the story of a community's health.
But hang on, before we can even start measuring disease, we've got to agree on what health actually is. And this definition from the WHO back in 1948 is, well, it's pretty famous. It reminds us that health is so much more than just not being sick. It's a state of complete physical, mental, and social well-being. So for us, good oral health isn't just about the absence of cavities, is it? It's much bigger.
Right, so let's get into two of the most fundamental measures you'll ever come across, incidence and prevalence. And honestly, this bathtub analogy is the perfect way to get your head around it. Think of incidence as the flow of new cases. It's the drip, drip, drip from the tap into the tub. Prevalence, on the other hand, is all the existing cases at one specific moment. It's the total amount of water already in the bath.
So let's break that down a bit more. Incidence is all about new cases. It tells us about the risk of someone developing a condition over a certain period. A classic dental example would be, say, the number of new cavities that pop up in a group of 12-year-olds over the course of a year.
Prevalence, though, is different. It's not about the flow. It's a snapshot in time. It tells us the total number of existing cases. So, you might ask, what percentage of adults over 65 have periodontal disease right now? That's prevalence, and it's super important for things like planning how many dental services a community needs.
Okay, another crucial distinction to make is between mortality and case fatality rate. They sound similar, but they measure very different things. Mortality is about the risk of death from a disease in the entire population. But the case fatality rate is much more specific. It's the risk of death just among the people who have been diagnosed with a disease. And believe me, they can paint two completely different pictures.
This comparison makes it crystal clear. Take coronary heart disease. Loads of people are affected, so its impact on the whole population, its mortality, is pretty high. But thanks to modern treatments, if you get it, your personal risk of dying from it, the case fatality rate, is relatively low. Now flip that for tetanus. It's super rare, so its overall mortality is almost zero. But if you're unlucky enough to get it, it's incredibly deadly. So it has a very, very high case fatality rate. See the difference?
Okay, so we know what we're measuring, but how do we measure it? That brings us to our next section, the epidemiologist toolkit. We're going to look at the different study designs they use, because you can't use a hammer to fix a watch, right? Different questions need different tools.
So yeah, what's actually in this disease detective's toolkit? How do we get the evidence we need to spot these patterns? What methods are we using to test our ideas about what's causing a disease, or maybe even what could prevent it?
Well, at the highest level, you can split the toolkit into two main types. First, you've got observational studies. The name says it all, really. We just watch and measure what's happening naturally, without interfering. And then you have experimental studies, where the researcher actually gets involved. They introduce some kind of intervention, like in a randomized controlled trial, to see what happens.
Okay, let's look at three key types of analytical study. First up, the cross-sectional study. Think of this as a snapshot in time. It answers the question, what's happening right now? Next, we have the case control study. This one looks backwards in time. It's retrospective. It asks what past exposures might have caused this. And finally, the cohort study. This one looks forwards. It's prospective. It asks what will happen to this group over time.
Now, of course, no study is perfect. Any investigation can have errors, and honestly, understanding and minimizing those errors is what separates good, trustworthy science from bad science. It's absolutely critical.
So you've basically got two big types of error to worry about. First, there's random error. This is just chance, the natural variation you get in any measurement. You can reduce this by having a bigger sample size. But then you have systematic error, which we usually call bias. This is a flaw that's actually baked into the design of the study itself. And here's the kicker. Making your study bigger won't fix bias. If the design is flawed, it's flawed.
I love this analogy. It makes it so clear. Imagine you're shooting at a target. Random error is like your shots being scattered all around the bullseye. They're not very precise, but on average, they're in the right place. Systematic error, or bias, is different. That's like all your shots being tightly clustered together, but they're all way off to the side, completely missing the bullseye. They're precise, but they're not accurate. What we want is both precision and accuracy.
Right, so we've covered a lot of theory. Now for the really important bit. Let's bring all of this into the clinic. This is where we connect the dots and see how all this stuff is the absolute foundation of the evidence-based dentistry you're going to be practicing.
And you'll see that epidemiology is literally everywhere in dentistry. You know, when we monitor the prevalence of tooth decay in school children, that's epidemiology. When we identify that things like smoking are risk factors for gum disease, that's epidemiology. When we test a new fluoride varnish to see if it actually works, you guessed it, epidemiology. All that evidence is what informs the big public health decisions, like water fluoridation, right down to the specific advice you'll give to your patient sitting in the chair.
And that brings us to our final and maybe most important section, your role in public health. Because as a future dentist, your job is about so much more than just treating the one person in front of you. You are going to play a huge role in the health of your entire community.
So I want to leave you with this question to think about as you continue your studies and eventually go into practice. What is the biggest oral health threat in your future community? And how could you use these ideas to investigate it? Never forget that you're not just a clinician. You're a guardian of public health, and you're now armed with the powerful, detective-like tools of epidemiology.